testicles. You look at the testicles in the male, and then you look for the ovaries in the female. The ovaries are in the pelvic cavity, and then in the female, in the males, we will look for them. So you're going to open all the way to the penis in the male cat. We just have to look at every single organ. Okay. In addition to this one, so the gonads produce the gametes. Gonads are sex organs. What are they? Testes and the ovaries. These are the ones where the gametes are formed. What are the gametes? These are your egg cells or oocytes in the females, right? And the sperm in the male. So the branch of medicine for females is called gynecology. For males, it's urology. So today we're going to talk about the male reproductive system first because it's easy. Well, not really easy, but it's not as complicated as females. Males only have to deposit the sperm and that's it. The females, they have to take care of providing board and lodging for the new baby. So we have an extra job. Okay? So for the males, there's their organs. There's the bojangles, there's the testes, the family jewels, right? This is where the gametes are formed. See? And then there's accessory organs. What do you mean by accessory organs? The accessory organs are they are there. Their secretions are vital. They're very important to the health and the survival of the sperm. So the accessory organs are the seminal vesicles, the prostate gland, and the vulvourethra gland. Another term for this one is Cowper's gland. Okay? So, let's look at the testes in males. First of all, here it is. We know that the testes, is the testis in any body cavity? Absolutely not, right? It's not in the pelvic cavity. First of all, when we were in our mother's belly, all of us had the potential to become male or female, right? It could be. It is the what makes you female and what makes you male. So all of us in the pelvic cavity. Do I have a drawing of the baby? Right here, okay? Right here in the pelvic cavity. This is where our gonads, by the kidneys. So where you remember the kidney in the cat, right? That's where our primitive gonads were, okay? It is the presence of testosterone that will make the baby male. If there's no testosterone, then you're a female. And so, in the presence of testosterone, those gonads become male gonads. So, this is what happens. In utero, while the mother is still pregnant, there's high level of testosterone in the male baby. That high level of testosterone is very important in forming the male gonads, the testes. So, then it becomes testes. And it directs the movement of the testes, the descent. The testes has to descend, has to come out. Okay? So again, all of us, we all have our gonads. Oh, there's our model right there. Right here. Where was the primitive gonads? Initially, right up here. That's why it's called paramesonephric. It's right here by the kidneys. This is where the gonads were. Okay? And then if there's testosterone, I'm going to become a boy. So the testosterone will guide the development of the male testes. You start developing sperm-producing cells, they're called spermatogonia. And the gonad then will be moving down to where it will be right there. Okay? And so there's what you call a gubernaculum testis, nothing but connective tissue. Have you ever gone zip lining, right? You zip line, and that's really what's happening. It zip lines and it goes down here. Now look at this one, okay? You look at this. That again, I said the primitive gonads was inside inside your abdominal pelvic cavity. Do you follow? And then before birth, it's supposed to descend. How does it go out? It's going to go through the inguinal canal. Here, the inguinal canal, right? So, both of us, male and female, both of us have an inguinal canal. Except in males, it's actually pierced. You see? It's actually pierced so that your gonads can come out. In females, it's not pierced. It's present, but it's intact. It's closed. The fact that this inguinal canal is actually open, and what came out? The testes, right? Where was the testes? Inside the abdominal pelvic cavity, right? Which means that there is communication between the abdominal pelvic cavity and right here. So that's why inguinal hernia is common among females or males?
Males.
Males. Because why? There is a real opening. Do you have inguinal canal? Yes. It's just not open. Okay? It's not open. So, hernia, not too much a problem for females, but very real problem for males because the testis descended. Why does the testis have to descend?
Because the sperm is very temperature
It's
sensitive.
very good. Temperature sensitive. The testis has to descend. If it didn't descend, I'm sure you've heard of this one, cryptorchidism, right? This one is undescended testes, and they say by the first year of life of the baby, that usually descends. And within maybe 6 months, even if it's still undescended, it's very easy. They just go through the inguinal canal and then they can just guide it down. It has to be pulled down. Otherwise, the testis will not be able to make sperm. This one is 1 degree cooler, and that's what it wants. It stays there, it's hot, it's not going to be able, the spermatogenesis, the formation of sperm, will be affected, okay? So I want you to look at this picture over here. This is the location of the testis is in the scrotum. And you see on the right side, right here, you see muscle here, right? There's 2 sets of muscles here. This is the cremaster muscle, which is an extension of your internal oblique right here. So skeletal muscle. Then there's also another layer of muscle called dartos muscle, which is smooth muscle. So you have smooth muscle and skeletal muscle covering the scrotum, and then on the other side here you see blood vessel. So what do you think? What does muscle do? What is it? What's the function of muscle? It contracts. So when do you think these muscles of the scrotum are very important to help in thermoregulation? When it's cold or when it's hot?
When it's hot. Or cold.
When it's cold.
Sorry.
So when it's cold, the testicles will shrink, or these muscles will contract to bring the testis closer to the body cavity because it's very temperature sensitive. Now, look at this on the left side. I usually ask this on the test. Okay, so don't forget this one. When it's cold, the muscles contract to help in thermoregulation. And now when it's warm. What about when it's warm? So, look at this. You notice, you see the artery, the testicular artery, the red, there's only a few of them, right? I see 2 here. But there is a plexus of veins, testicular veins. You see a lot of them, a plexus of veins. And remember, the veins are supposed to bring the blood back to the heart. So, when it's hot, that means this testicular artery is actually carrying hot blood or warm blood. You see, on its way here, the heat, this plexus, what the plexus of veins do is they carry the heat away from the testes. So your blood, your testis is still getting blood, but the heat or the warmth is being moved away from the testicles and back to your abdominal pelvic cavity. It is very important to maintain temperature in your testes because that is where spermatogenesis happens. Do you have any questions so far? Let's cut open the testis, and that's what you need to do with your cat also. You locate the testis and then you cut it open. And so here's the testis. This is how it looks like in your cat, okay? Then I want you to cut it. And so you see, when you cut it, it will look like that. It's made up of nothing but the same like your kidneys. It's nothing but tubes. It's called seminiferous tubules. Seminiferous tubules. That's seminiferous tubules. Your kidney is made up of tubules, the renal tubules. Here is called seminiferous tubules. So you have lots and lots of them. And I want to cut open those seminiferous tubules, okay? I want to cut it open and see. Look at this one, higher view. And what they did is they just cut, and look at, like when you cut this one, and you look at it like that, look at the sperm with the tail swimming. I imagine it like in the pool, like when you're on the side of the pool, you're just resting, you're dangling your legs. There's the leg of the sperm, see? It's just waiting to go in your tubing, right? Okay? So, each and every tubule is made up of sperm. Let us now, do you have any questions so far? Let's now look at, I looked at the anatomy. I want to look at the cells that make up my testes. What are the cells that I can find there? Okay. Within the tubule, so I see cells inside the tubule. I also see cells in between the tubule. So like in the pink one, there's cells there. They're in between the tubule. And within the tubule, there's cells there. I'm sure you can guess what's the most predominant cells here in the tubule are your sperm cells. Okay? The sperm cells here are in varying stages of maturation. I want you to know this term, gonia. So anything that has this term, oogonia or spermatogonia, this refers to the primitive, the stem cell, the germ cell. Like your osteoprogenitor cells, that's the stem cell that becomes your bone cells, remember? Here, the spermatogonia is the stem cell and it becomes the spermatocyte or the sperm cell. So it matures. Oogonia is the primitive egg cell, and when it matures, you call it oocyte. Okay? So you have here the sperm cells. Some of them are called spermatogonia. And this one up here, right here within the lumen, I'm sure this is the spermatocyte. This is the one that's ready to go inner tubing and to swim into the vaginal area, go up, and look for the egg. Okay? Okay? And I was going to say something after that. In addition to the spermatogonia, see spermatogonia, I'm going to highlight, magnify it even more. Okay? Here. So there's my sperm cells, varying stages of maturation. And then in addition to the sperm cells, so I'm looking at the cells that make up the tubules. Within the tubule, the seminiferous tubule, it's made up of sperm cells, in varying stages of maturation. There are also what you call Sertoli cells. This is the second group of cells. Another term for them is nurse cell or sustentacular cell or sustentocyte. I think that's what the book uses. So this, you can either call it Sertoli or nurse or sustentocyte. They're all the same. I like the term nurse, Nurse Jack. They nurse the sperm. Okay. What's the function of the sperm cell? You know the function of this one, right?
To carry on.
Yeah, to carry on the chromosomes. What is the function of the nurse cell? That's why I like to call it nurse. It nurses. It supports the sperm cell. It also creates a blood testis barrier. Okay, let me ask you. These sperm cells, this is the one that's going to meet with the with the egg cell. What is the chromosome count of the sperm cell? 23. Very good, right? Humans have 46 chromosomes, right? So this one has already matured. So this sperm cell has 23 chromosomes. The eggs, the primitive one, they still have 46, no problem, right? But this one has 23. Is this human or not? No, very good. Humans have 46 chromosomes, which means this is considered an antigen. It is non-self. So if the male blood can see that, it will create an immune reaction. So what this nurse cell does, see, it creates a blood, see, there's a blood testis barrier so that the male can carry the sperm, no problem, of the male attacking the sperm. Because again, is this sperm human or not? It is not human. You understand? So those are the two cells that you find in the tubule. Now, in between the tubules, right here, in between the tubules, there are cells. There's another group of cells there. Those cells are called the Leydig cells. Or the proper term is interstitial cells of Leydig. What does that mean? They're in between the tubules. What is the function of the Leydig cells? They make testosterone. The Leydig cells make testosterone. Testosterone is the key for spermatogenesis to be successful. You need normal levels of testosterone for this spermatogenesis to happen. And that's why this Leydig cell is very important. They make testosterone. Another function of the Sertoli cell. So in addition to forming the blood testis barrier, the Sertoli cells also make androgen binding protein. So Sertoli cells are filled with androgen binding protein. What is the androgen that they bind? They will bind the androgen testosterone. So can you picture in your head? This is my Leydig cell. It will make testosterone. And then where's the testosterone going to go? It's going to bind with the nurse cells, the sustentacular cells right here. So transfer it here so that the sperm cells are always exposed to good levels of testosterone and they can proceed with spermatogenesis. Do you understand? Mm-hmm. It's very easy, isn't it? See, I told you that's our male reproductive system, very easy. One more time, we review the male reproductive system. The main organ is called the testes, right? And you know where it's located. And the testes, and here's how it looks like. When you open the testes, it's made up of tubules. You call it seminiferous tubules. And what is contained in the seminiferous tubules are my sperm cells and the sustentacular cells. The job of the sustentacular cells create a blood testis barrier and also help, because how do they help? They bind the testosterone. They have androgen binding protein. So making sure that my sperm cells are always exposed to normal levels of testosterone. Where did the testosterone come from? It came from these Leydig cells right here, in between the tubules, in the pink area. So the Leydig cells make testosterone, and then they're stored by my Sertoli cells. You understand? Okay? So I want to look at this spermatogenesis. Spermatogenesis is a different type of reproduction, cell division. How do they divide? They divide by, very good, meiosis, not mitosis. So do you remember with meiosis? I'm sure you remember this. So we start with 46 chromosomes, 23 from the mom, right? And 23 from the dad, right? To prepare, you double up. And then with meiosis, you go through the first set. Meiosis 1, you go through prophase, metaphase, anaphase, telophase. But how do they divide? They divide this way. So you produce two cells. One will contain the mommy plus the copy, and then the other one will contain the daddy genes plus the copy, and then another set of prophase, metaphase, anaphase, telophase, so that you will produce 4 cells with 23 chromosomes. You remember this? This is just a review. This one, but look at the meiosis. Why is it? Have you ever heard of some? Maybe you have some brothers or sisters don't look like you, and then always they get teased like you're the daughter of the milkman, or they always. And that's because during prophase, this one, the first set right here. During prophase, where the mommy and the daddy where they meet, there is a tremendous chance for crossing over. There's an exchange of genetic information. And can you imagine all of those chromosomes, if all of them cross over, there will be a lot of variation in the expression of the features of the baby. So you will both have the same parents, but you will not look like each other. It depends on the degree of crossing over. Okay? But I want you, have you ever heard of the term Mac Daddy, right? The guys can be a Mac Daddy forever. Well, even if they're 8 years old, 9 years old, they can still be a daddy. Why? With females, we go through menopause. When we hit menopause, no more. Do they go through menopause? No. Why? Look at this, okay? That's why they have to cut the Bojangles if they want to. What do you call that? What is that called? Vasectomy. Vasectomy, right? Because they're always going to form sperm. Look at this. Very important for us to know, okay? There is the spermatogonium. This is the primitive sperm cell. So you remember the two right here? If you see this picture right here, the two. So by the way, looking at this, what do you think is the tissue type? Yes, very good. Epithelium, right? It's very cellular. There's an exposed surface. So it's called germinal epithelium. Same for females, same for males. Okay? Look at the spermatogonium of males. Look at this. This explains why males can be Mac Daddies forever. The spermatogonium of males only divide always by mitosis first. Look at this. So this one that's stuck right there, right here against the wall of the tubule, they always divide first by mitosis. Remember, mitosis produces 2 cells. So one stays in the reserve, and this one is committed to divide by meiosis. And so that's why they always have the reserve. This one will divide by mitosis again, reserve, meiosis. Mitosis again, reserve, meiosis. So that's why they can become fathers. Abraham was how old? 90 or 100 when he gave birth to Isaac, right? In the Bible, see? Because of the Mac Daddy. You understand? Okay? So let's look at this one. Let's look. Do you have any questions on this one first? Do you have any questions on the explanation? Okay? By the way, don't forget with males, once you remember you have the X and the Y, X and the Y, so that when you produce your 4, right, one will have X, the other one will have Y, one will have X, the other one will have Y. Okay? Don't forget, there was a question in your test.
Do women just have X's?
XX, yes.
Okay, because the way that's explained is like XY on the mom.
Oh, sorry.
I think you have
Oh, no. This was the male.
yeah, the
This-
one on the top. You said the black one was the mom. You did X, Y, X, Y.
Oh, sorry. XX. No. This is a boy. This is a boy. This is the sperm.
Okay.
That's the sperm.
Okay.
For the egg cell, it will just be egg. This is the boy.
Okay.
So the boys have the XY. Okay. But and remember, so who carries the Y chromosome?
No.
The boy. Remember King Henry? He killed all his wives one after the other because he couldn't have. He says that the wife couldn't give him a baby boy. Whose fault was it? It's his fault. I remember that was asking her finally that okay. So let's go back to this one over here. This is the process called spermatogenesis. Do you have any questions on how we form the sperm cell? Let's look at the anatomy of this sperm cell. Right here, the development. So I formed this. This is already this one. Okay. By the way, in males, all four of them are healthy. Okay, all four of them have to be healthy and all have to develop, be functioning. And this is how it looks like. In the beginning, it's pretty. It contains the nucleus, you have the cell membrane and all the organelles in the cytoplasm. But as it matures, the sperm that meets with the egg looks like this. The sperm contains nothing but the head, which contains the 23 chromosomes. So you see that it's 22 plus the X or the Y, okay? And then a midpiece that contains the mitochondria. The mitochondria is for what? Energy. And then this is the flagella, which is for what? For swimming. Is there any other organelle from the sperm? Nothing. Really, the energy is just to power the sperm so that it can do its job. It needs energy. Can you imagine the life of a sperm? Just think about if you were a sperm. Think about your life. You're going to be dumped. You're going to be deployed in enemy territory. Seriously, the female reproductive tract is enemy, right? It's like it's a foreign country to them, and they're attacked by a lot of enemy forces. There, the acid pH. Maybe there's bacteria in there, the mucus in there. It's just not number one. Number two, they have to climb, ascend the mountain, the uterus. And number three, they have to split off because they don't know where you ovulated. Did you ovulate on the right or on the left? That's why you have to have lots of functioning sperm. In addition to this head, this acrosome. Every sperm will have this helmet called the acrosome. This acrosome contains very acid hydrolases, enzymes. That's important in protecting it as it moves, right, through the female vaginal area, and also when it meets the egg. The egg is just like the egg that you buy in the store, has a hard shell. So that acrosome has to crack that egg. So that when it has cracked, so you release all of that, the acrosome, that will be all used up when it cracks the egg. What's left is this nucleus with the 23 chromosomes, and it fertilizes the egg. That is the only contribution of the sperm in the new life, is only the 23 chromosomes. All the other, you know the cell, right? A cell is made up of the cell membrane and all the organelles there. All of those other organelles are contributions from the mother. The only contribution from the father is the 23 chromosomes. But they're very important. Without the 23 chromosomes, you cannot form the new individual. So, can I ask you, what do you think is a normal sperm count?
In the billions.
Very good.
20 billion.
You know, the normal ejaculate is between 3 to 5 mils, okay? And each mil should contain 50 to 150 million sperm. You need those, so 150 times 5 plus 150 times 5, 750, right? So you need all of those millions because, like I said, they're going to be deployed and a lot of them will have to sacrifice themselves. It's like there's power. They're supporting each other in this long hike. And they go to the uterus, they still have to move all the way to the fallopian tube. Fertilization happens in the fallopian tube in general. So you see all of that hard life just for one sperm to survive. Even the egg is not friendly. They have to crack that egg. So you need all of those millions. Crack it. Once it becomes what you call fragile and there's a crack, one gets lucky, go like it always reminds me of, you watch football and all of them are crowded and then after some after a few seconds you all jump, you say touchdown. You see that finally the guy was able to do a touchdown, but in the beginning there's the crowd covering them. That's the same thing with a touchdown for your egg, okay? And that's why it's to be given a diagnosis of being infertile or sterile. That's just such a big thing, something very serious. I think that's why fertility clinics are they're very expensive because it's a lot of work. So they look at the semen and they look at microscopic analysis. They look for normal sperm. This is how a normal sperm looks like. Is there any germ cell included in the ejaculate? If there's germ cell included, then you're sterile. A germ cell is not a fully developed sperm. It cannot impregnate, cannot fertilize, or maybe there will be some with two heads, maybe a kinking folding of the tail like that. If it's folded like that, it can't swim. It has to have very nice shape. That's why some of them will have maybe not big coiled tails. You have to have a very nice shape like this. Okay? So now we have seen what happens here. It makes the sperm. By the way, so if you look at the tubules over here, okay, these tubules all the way to the the vas deferens here. That's why it's called vasectomy. This is your vas deferens. This is nothing but the tubes, right? This is filled with sperm all the time. And like freeze, they don't have to be released all the time. They survive there even up to 7 months, they say. That's why when people go through vasectomy, they still advise them for the next few months to still abstain or is the word abstain? Abstain or what's the anyway, abstain from sex because they can still impregnate. What happens to the sperm? They just die. They undergo, remember natural cell death called apoptosis? In sex cells, what's the term for natural death of sex cells? Atresia. This is nothing but apoptosis. It's the same, okay? But when you see this word, it means natural cell death of your sex cells, your sperm or your egg cell. So they just undergo normal degeneration. After all, it's just made up of organic and inorganic compounds. And then it just degenerates. Okay? Okay. You remember, I told you that the sperm, the seminiferous tubules contain nothing but sperm. Yes, they're going to go on a long trip. But they're being released naked. That's what I call it. It's a naked cell because it has nothing. It has the nucleus, the 23 chromosomes, it has a tail, it has the mitochondria, but it's carrying nothing. It's like you're going hiking, but you don't have anything. You may die of hunger. That's the same thing with the sperms. So that's why, see, look at this. On its way out, it has to get some care packages from the three kings. I call them the three kings. So the three accessory organs for the male reproductive system, the seminal vesicle, the prostate gland, and the Cowper's gland. They're there because their secretions are important to the life of the sperm as it leaves the male reproductive system. While it's here, it's okay. It's getting nourishment from you. But once it leaves, it's going on a hike. It needs food. Remember, what is the sperm made of? Just the nucleus, mitochondria, tail, nothing else. So look at, the first king is called the seminal vesicle. On its way out, it's going to get a care package from the seminal vesicle. What is the seminal vesicle giving your sperm? The book enumerates a lot. I'm just going to highlight the more obvious ones. Fructose, which is what? Yes, for energy, right? So that's the one that can go to the mitochondria, give the sperm ATP so it can go swimming. Okay? It also gives lysine proteins. Clotting proteins. Similar to fibrinogen. That's why semen clots. And that clotting is very important in fact. You know when it's too cold, don't you huddle together? To at least you sacrifice yourself, but your babies are still warm. That's what the animals do. That's the same thing with the sperm. When they're deployed in the vaginal area, it's a lot of them. If you spread them like that, they may possibly die. But clump them together, at least the group inside is protected. You understand? They have to adjust to the vaginal area. Yes.
Could it also be a protective measure against other semen?
Other semen.
Let's say your partner is not too faithful and they, are with the mailman.
Oh, yeah.
Could it be? Yeah, so it would be like yours is protecting from the other one.
Yeah. I never even, that's the first time I heard that explanation. Okay, prostate gland, the next key, prostate gland. The prostate gland actually gives what you call seminal plasmin, which is antibiotic. This is easier than remembering the word seminal plasmin. So it gives antibiotics. Why? Isn't there always germs in the vagina, right? So this antibiotic at least helps, protects the sperm, and it also gives lysine proteins. So after it clots, it lyses. It's like, they huddle together, give some pep talk, and then after they say, oh, it's not too bad, let's move on, right? March forward. So now they're ready to march. They have adjusted. Last, you have this Cowper's gland. The Cowper's gland, you see, it secretes mucus. And the mucus is alkaline. It's very important because right here, there may be some PP, which is usually acid and pH. So, see, the Cowper's gland moves ahead to neutralize the urine there. Maybe there's leftover urine there. So that semen never contains urine. Don't forget that. What is the composition of what you call semen? Semen is sperm plus secretions from the three kings. No urine. You see the importance of the three kings? How they play an important role. Look at this prostate gland, by the way, and I want you to look for this in your cat. Feel it. It's like a donut. Look at the anatomy of the prostate gland, and it's right there by the urethral sphincter, the urethra right here, and it naturally enlarges. As males get old, this one enlarges, which explains why as males get older, they will have feeling of fullness, and that after they have emptied their bladder, they feel that there's still something in there that they have to go back to the bathroom. Urinary frequency. That's because of enlargement of the prostate. And that's normal. Okay? It's a donut. You understand so far? Very easy, right? So the male reproductive system is made up of the testes, and you see the three cells here, the sperm, the Sertoli cells, and the Leydig cells. You know the function. And then the sperm, as it leaves, right here, it gets secretions from your seminal, the three kings. This one, you know the function, why it's important, and then it keeps moving, it gets secretion from this one, and then finally from this one. And then you ejaculate, but they call it semen. Semen never contains urine. Now, this one starts happening when the baby is born. Does it start happening? Does this cycle start happening when the baby is born? The moment? No. This happens when we hit puberty. This is regulated by your hormones. Don't ask me why, okay? So when in utero, in the mother's baby, in the mother's belly, there's high testosterone level to make you a boy. You form your boy parts. But once you're born, the testosterone level in babies, it goes down. They already form their boy parts. So testosterone levels go down. Remember, testosterone is the key for spermatogenesis. So they have the spermatogonia in their testes, but it's not producing sperm. So when they hit puberty, which is how old? How old is puberty? 13, 14. Okay, when they hit puberty, don't ask me why. This is maybe God's way of making sure that babies don't become fathers, right? They can become fathers. But when they hit puberty, the hypothalamus starts making this gonadotropin releasing hormone to tell the pituitary. So you remember this. If you remember this is the same flow chart for females. It's the same. The pituitary starts secreting these two hormones, FSH and LH, follicle stimulating hormone and luteinizing hormone. So what is the target of these two hormones? The testes. There's no other organ in males, it's just the testes. Okay? One more time. When we hit puberty, our brain, our pituitary starts secreting FSH and LH. And look at the target. The target in males is just the testes. The target of the FSH is the seminiferous tubule. There are two cells in there, right? The sperm cells and my Sertoli cells. The Leydig, the luteinizing hormone, L for Leydig, it targets your Leydig cells to make testosterone. So, remember what we talked about? The function of your sperm for spermatogenesis, the function of your Sertoli cells to make androgen binding protein. It's regulated by the hormones. So, we just include this now, these hormones, in your notes in the beginning. Remember the beginning notes? I said this is the function of your sperm cell. This is the function of the Sertoli cell. This is the function of your Leydig cells. Now you add to your story, these functions are regulated by my hormones. What are the two hormones? FSH and LH. And when do they happen? At puberty. That is a gift from God. Okay? You understand? Okay. I want you to look at the effect of testosterone. We know testosterone is the key for spermatogenesis. You understand? Okay? But there is a metabolite of testosterone, see? Dihydrotestosterone. This one, this other form of testosterone is the key for developing the secondary sex characteristics of males. Like the voice, the sexy body, right? To look at protein synthesis, what else? Everything, the male, the hair in the face, everything, okay? And then they start bulking up, and that's why they start forming those muscles. Testosterone also increases red blood cell production, more so than estrogen. Okay? And this is what is so attractive to athletes. Okay, there is the synthetic steroid, synthetic testosterone that they sell out there. But that synthetic testosterone is a purified form of testosterone that does this, and the secondary increase muscle bulking. So they look sexy, they look powerful and strong. But what is the scare with using those synthetic steroids? How about this one? What do you think? Can you predict if there's increased RBC in those males taking synthetic steroids? Can you predict what can possibly happen to their blood? If there's increased RBC. No, what will happen? Blood is already thicker than water to begin with, right?
Yeah.
You add to the thickness of blood, you add this to the thickness, you're adding more possible. Yes, very good, right? So possible cause, possible candidate for stroke. Yes, they had a very colorful active career. Then many years from now, you see them having a stroke. Or I'm sure you've heard of stories where they're running, they collapse and they die. Because they were taking this one, number one. Number two, look at this picture over here. The synthetic steroid that's being sold out there has nothing to do with spermatogenesis. So the synthetic steroid only promotes this one, the muscle growth, this one. But it looks like the same, right? So what happens when you ingest that is you're telling your brain, you're giving it the wrong message. You're telling your brain you have high levels of testosterone. So will the brain secrete FSH-LH? No, because this operates on a negative feedback mechanism. So what happens? Will they form? No, because the testosterone that they ingested only does this, not this. So that's why they become sterile. And what happens to the testicle? It will shrink, called sweet peas. Why will it shrink? It's no longer working. You don't need it because of the synthetic steroids. You understand?
Is that reversible or is it irreversible?
It can be reversible when you stop, but a lot of times because of the chronic pattern or the long time that they have been taking it, they just become sterile. It just stops. It just stops. You have any questions on the male reproductive system? Very easy, isn't it? Okay. So on Monday next week, we start with the female reproductive system. You understand why hernia is more common in males? Now can you explain to your friends why you don't advise them buying the synthetic steroids in the market? You please tell them the difference, okay? You explain to them that negative feedback, remember the word negative feedback, in your brain. You're giving your brain the wrong message. And they're going to end up with sweet peas. They will look sexy, and plus, more than the sweet peas, they may die from thickening their blood. That's very important. Okay? So, don't forget your test. Bring it on Monday, please. Okay? It's due on Monday along with your renal. Either your analysis, give it to